Welcome to today's investor update, which has been timed to coincide with Amplia's June quarter Appendix 4C and quarterly update. Before we proceed, and in the spirit of reconciliation, Amplia acknowledges the traditional custodians of country throughout Australia and their connections to land, sea and community. We pay our respect to their elders, past, present and emerging, and extend that respect to all Aboriginal and Torres Strait Islanders listening today. So the last quarter has been a productive and exciting one for Amplia, and once again, we thought it would be valuable to summarise some of the key achievements and the implications of these for our company, as well as provide an opportunity for shareholders to ask us some questions. So during today's presentation, I'll first of all touch on the 4C that was released this morning, and then step through the presentation, which was released to the ASX this morning, Melbourne time. I invite you to submit your questions during the presentation using the Q&A function in Zoom, and I'll do my best to respond to these after the presentation. So in reference to our 4C quarterly cash statement, we reported today that at the end of June, the company held $4.1 million in cash. During the reporting period, we had consumed $1.3 million, of which approximately 3/4, or $993,000, was dedicated to research and development, primarily associated with the closeout of our phase 1 clinical trial of AMP945. In the coming quarter, expenditure is expected to increase. In the coming quarter, expenditure is expected to increase as we ramp up activities for phase 2 enabling activities, and I'll describe these in greater detail later in the presentation. Please take note of our disclaimer. So many of you will have seen this slide before, but just to align us all on Amplia's focus areas before we proceed, Amplia is developing new drugs which inhibit focal adhesion kinase, or FAK. The reason we're targeting FAK is because it plays a central role in two pretty significant disease areas, cancer and fibrosis. So in fibrosis, we expect that our FAK inhibitors will be most likely used as single agent antifibrotic agents. And in cancer, we expect that our FAK inhibitors will be used as combination therapies alongside other chemotherapies, in particular in cancers where fibrosis plays a role to support tumour growth, such as in pancreatic and ovarian cancers. The two indications that Amplia is most interested in at present are pancreatic cancer, which is a particularly difficult to treat cancer. It's often detected late when it is spread to other organs in the body, such as the liver. And patients who are treated with the best therapies that are currently available for metastatic pancreatic cancer have a median survival time of around about 6 to 8 months. So new therapies for pancreatic cancer are desperately needed. We're also focused on pulmonary fibrosis, which is a devastating progressive disease with relatively few, rather poor treatment options at present. And again, the link between these two therapeutic areas is that they're both in some way fibrotic in nature. And Amplia's drugs are designed to address this underlying fibrotic nature of both these illnesses. Also, as a reminder, Amplia holds orphan drug designations from the FDA for both pancreatic cancer and idiopathic pulmonary fibrosis. If we are to describe what Amplia is doing using a pipeline diagram, we can see that our most advanced development candidate, AMP945, is on the brink of moving into phase 2 clinical trials in both pancreatic cancer and pulmonary fibrosis. And while the focus on phase 2 is probably the headline for Amplia at the moment, we're also looking at the utility of AMP945 in other oncology indications, in large part through our collaboration with the Garvan Institute in Sydney, but also through other channels. In addition, we're exploring the utility of our other FAK inhibitor, AMP886, in other cancers and fibrotic diseases, where 886's unique selectivity profile may provide an advantage over other drugs that are in development. So as I mentioned, this has been another very productive quarter for Amplia, and we've been able to push forward on a number of fronts. Firstly, we completed negotiations of a collaboration agreement with the Garvan Institute, and I'll describe in a few moments why this is so important for Amplia. Through that Garvan collaboration, we also collected and reported some really positive preclinical data, which further underpinned our rationale for running phase 2 clinical trials of AMP945 in cancer and in fibrosis. I think most importantly though, on time and on budget, we completed dosing in our phase 1 clinical trial of AMP945 in April. And during the remainder of the quarter, we were busy preparing the data collected during that trial for analysis and then unblinding the trial. And you may have noticed last week that we were pleased to announce that the trial had been a success. I'll go into a little bit more detail about the data that we collected and the significance of this later on in the presentation. And then lastly, we raised $3.8 million in May for the purpose of properly preparing the company for phase 2 clinical trials. So as I mentioned, in June, we completed the collaboration agreement with the Garvan Institute, and we've spoken previously about the depth of experience in fact biology that Paul Simpson and his team at the Garvan bring to this collaboration. The collaboration has already given Amplia further scientific evidence that its FAK inhibitors deserve to be tested in patients with pancreatic cancer and fibrosis. But another reason we've been keen to formalise this collaboration is because it's also about the future. It's about finding new opportunities for our FAK inhibitors beyond those that we already know about. Several of these more forward-looking studies are already underway or are being planned. So we really do think that this collaboration is going to be, or already is, a win-win for both Amplia and Garvan, as it pairs Garvan's expertise in FAK biology with Amplia's clinical stage FAK assets and skills in drug development. Under the collaboration, Amplia benefits from Garvan know-how and receives first rights to arising intellectual property. And in return, Amplia supports research in the Garvan, at the Garvan directed at the utility of Amplia's FAK inhibitors in cancer and fibrosis, while also opening the door for translation of Garvan know-how into clinical benefit for patients. So I'd just like to now touch briefly on some of the data that's arisen from the collaboration so far. You may have seen this data in our April presentation, but just as a reminder, this is an experiment where we looked at whether AMP945 could inhibit the production of collagen, which is a key building block of fibrotic tissues. This data shows that in vitro, increased concentrations of AMP945 significantly decreased the amount of collagen produced by fibroblasts, which are the key cell type responsible for the production of this building block. So this data here speaks really to the antifibrotic properties of AMP945. We then went on to explore the anti-cancer properties of AMP945 in a mouse model of pancreatic cancer. And the left-hand panel of this slide shows the design of this experiment. First of all, we established tumours in mice and then treated those mice with AMP945 for 4 days, then stopped treatment with AMP945 and on the following day, treated the same mice with 1 shot of gemcitabine and Abraxane, which is a standard of care for pancreatic cancer patients. When we did that, we noted that we had a positive impact on some important tumour markers. One of these markers is called cleaved caspase 3, and it's a marker of tumour cell death. After treatment, we saw a significantly higher level of cleaved caspase 3 in these tumours, telling us that more tumours in these mice were dying. Another marker is called Ki67, and it's a marker of proliferation, so it's the sort of flip side of cleaved caspase. It's a sign of health. And after treatment with our FAK inhibitor, followed by gemcitabine and Abraxane, we saw a significantly lower level of Ki67 in these tumours, telling us that the tumours in these mice were quite sick relative to mice that had been treated with vehicle or AMP945 alone or gemcitabine and Abraxane alone. So the next step was to see whether the effects on tumour markers actually translated into a survival benefit in this model. And we reported this data in April. So sure enough, it did translate into a survival benefit. We reported that when we treated pancreatic cancer tumour-bearing mice with a combination of AMP945, gemcitabine, and Abraxane, mice survived significantly longer than mice that had been treated with either AMP945 alone or gemcitabine and Abraxane combination therapy alone. The median survival times in the AMP945, gemcitabine and Abraxane groups were 22 or 23 days, whereas in the combination group, where we combined AMP945 with gemcitabine and Abraxane, the median survival time was extended to 28 days, which represents a 27% improvement, which in this pancreatic cancer model is a very significant result. So this data is important because it further reinforces our rationale for testing AMP945 in patients with pancreatic cancer. And it shows that even in this highly aggressive disease model, our preferred combination shows promising signs of efficacy. So I'd now like to turn to a bit more detail about the phase 1 trial, whose results we reported last week. This trial was essentially run in 3 stages. In part A, we studied the effects of AMP945 in healthy volunteers who were given single ascending doses of AMP945. In part B, one of the part A cohorts returned for a second dose of AMP945, the same doses they'd had previously, but this time after giving them food before dosing. This was to see whether or not food has any effect on the absorption of AMP945 in the gut. In part C, we studied the effects of AMP945 in healthy volunteers who were given multiple doses of AMP945, again in an ascending manner. Throughout the study, we looked at safety and tolerability. These were the primary endpoints for this trial. And we also studied the pharmacokinetics of AMP945, or how well it's absorbed and excreted from volunteers in the study. We also collected samples to explore whether AMP945 inhibited FAC in these volunteers and to gain an initial understanding of the human metabolism of AMP945. These exploratory analyses are ongoing at the moment, and we'll report on them in due course. So when we analysed the data, we found the following. We found that the primary endpoint of the trial had been met and that AMP945 was indeed safe and well tolerated at all doses tested. We tested single ascending doses up to 125 milligrams, and we tested multiple doses up to 100 milligrams once a day for 7 days. There were no serious adverse events or withdrawals, and we were unable to identify any safety trends in the data. The half-life of AMP945 was such that it appears it can be dosed once daily, and we were unable to detect any effect of food on the absorption of AMP945. This is important because it will help patients in subsequent trials to adhere to the trial protocol, because it won't matter, we think, whether or not they take AMP945 before or after food. We were also able to show that that levels of AMP945 after oral dosing reached sufficient levels in the blood to inhibit FAC. So this is a graph showing how AMP945 is absorbed and eliminated from the blood after oral dosing. The solid blue line shows that when AMP945 is given after 6 days of prior dosing, it's rapidly absorbed and reaches a maximum concentration around about 2 to 4 hours after oral dosing. It's then eliminated from the blood over the following period of time. In this kind of study, we of course ask ourselves the question, well, are the levels of AMP945 that we're seeing in blood likely to have a pharmaceutical effect on FAC? And fortunately, based on what we know about AMP945's potency and other properties, we can model this, and our modelling tells us that with once daily dosing after several days, so after reaching steady state, median levels of AMP945 don't drop below what we believe will be levels required to inhibit FAC, which is depicted by the black dotted line on that graph. So this is really encouraging because it tells us that we're in the right ballpark to see pharmaceutical effects when we do progress into phase 2 clinical trials. So the significance of these results is that we're now in a position to initiate phase 2 studies of AMP945. If you've followed Amplia's story over the last couple of years, you'll have heard me say on multiple occasions that our development strategy for AMP945 has been to run this phase 1 trial in healthy volunteers and thereby build a platform for further development in both cancer and fibrosis. We've now reached the point where deployment of this strategy has borne the fruit we hoped for, and we're ready to move into parallel development in these 2 therapeutic areas. So respectively, we're aiming to initiate phase 2 clinical trials in pancreatic cancer patients in the 4th quarter of this year. And while pulmonary fibrosis and the pulmonary fibrosis trial is planned to run about 6 months behind that, aiming for around the 2nd quarter of 2022. And to these ends, we raised further capital in May so that we could properly prepare the company for these trials. So in May, we raised $3.8 million by issuing 16.8 million new shares to new and existing institutional investors. We were grateful for the support of our existing institutional investors, Platinum Asset Management and Blue Flag Holdings, and we were pleased to welcome Acorn Capital to our register during that raise. The funds are being used to get ready to start phase 2 trials in pancreatic cancer and pulmonary fibrosis. Specifically, we're working on the design, schedule, and costings for the pancreatic cancer trial most intensively at the moment. And the fundamental question that this trial will be designed to address is, could AMP945 improve the effectiveness of current pancreatic cancer treatments? We're also getting ready for the regulatory interactions that will be required for the trials to proceed both within and outside of Australia. And to this end, we're targeting an IND filing for AMP945 in the 1st quarter of 2022. In addition, we're manufacturing more AMP945 for use in our planned clinical and non-clinical studies. And when this material is available, we'll initiate longer-term toxicology studies to support extended dosing requirements of fibrosis clinical trials. So just to reiterate, the June quarter has seen Amplia become a company on the brink of entering phase 2 clinical trials with AMP945. The completion of that phase 1 clinical trial sees us successfully executing the development strategy we've been describing and ready to pursue opportunities in both cancer and fibrosis. The Garvan collaboration supports both the things we're doing today and offers the potential for tomorrow to open up new opportunities in the future. In the next couple of quarters, we expect to be able to update you on the final design of our pancreatic cancer trial, the regulatory interactions that we've had or that we have planned, and any new data that arises from our non-clinical studies that are ongoing. So I think at this point, I'll turn my attention to any questions that may have come in over the Q&A during the presentation. I did receive one question last night by email along the lines of, do we have any predictions as to the future sale or licensing of the drug in the if the phase 2 trial is successful? The position that we've adopted here is that we think we are most likely to maximise the return on our investment in any licensing deals if such transactions occur around or after phase 2. So now that we're entering phase 2, we agree and we have initiated attempts to increase our engagement with potential licensees. As for any financial predictions or potential deal structures, I'm afraid it's too early to comment on those at this point in time. Just again turning to the questions. Yeah, it's a good question. Okay, so in the slide on inhibitory concentration of AMP945 in phase 1, why did plasma concentration flatline after 18 hours? That's because the curve that we're looking at there is a median, is a description of the median concentration. So it's a relatively small sample size of 6 volunteers. So the sample size in each group there were 8 volunteers, 2 on placebo, 6 on active. And the most appropriate way to analyze a relatively small data set like that is to look at the median rather than the mean. And so that's what we've had. So what we've got there is a quirk of the numbers where the median at 18 hours happens to be the same as the median at 24 hours. When do you expect to have results of the FAC inhibition exploratory analysis from the phase 1? I expect that we will know the results of those tests probably around the end of August or into September. The truth of the matter there is that those samples, it's been extremely difficult to work up an assay for the particular samples that we collected during the trial. We were looking at skin punch biopsies, and the levels of FAC in skin are relatively low. And so we've had to work up an exceedingly sensitive assay in order to have any prospect of detecting the difference between inhibition and no inhibition. So we may not see anything in those assays when we run them, but regardless, the results should be available around August and September. I would say also, of course, that while those assays are incredibly exploratory because we're looking at skin, whereas the tumours that we're intending to hit with FAC are in the liver, where the level of blood perfusion and exposure to the drug is likely to be a lot higher. Why did the MAD study have a lower maximum dose than the SAD study? It's just the way the dosing schedule worked out. We were monitoring the exposures of the volunteers to the drug and comparing them to the no effect levels in our toxicology studies. And we worked out that after 3 cohorts, we had reached a level that appeared to be likely to inhibit FAC, and beyond which in healthy volunteers, it would not have been ethical to proceed. They're all the questions that I've received during the course of this presentation. So at this point, I'd like to thank you for joining our webinar today, which I do hope has been informative. As we move forward with our development of our FAC inhibitors, we'll be sure to keep you informed of any further developments. So at this point, I'd like to close the webinar. Thank you all for attending and wish you all a good day. Thank you.